Hello, Assalamualaikum warahmatullahi wabarakatuh, and my name is Haziq Iskandar, and good evening. So today I will be explaining about my final year project. So I'm gonna apologize first since my final year project, the previous final year project, the first one is quite different from this one, where my previous one is about optimization, but for this one I had to change the topic due to the certain circumstance that I cannot avoid. So for this one, my topic is preliminary study on optimum condition for iron sulfide removal by DTPA and K2CO3 ratio of mixture. So first I start with my abstract. So based on my previous, we have the same concept but different approach. So for this one, iron sulfide scale is considered one of the common problems of flow assurance in the oil and gas industry that affect the production rate. So it's the same thing as the previous one, but for this one, we focus on one thing and one thing only, which is the DTPA K2CO3. Now, this is different than the previous one, where the previous one, we try to find a multiple solution or multiple chemical that are able to help. But for this one, we only focus on one. However, for this one, we focus on the parameter that affect the effectiveness of the DTPA and K2CO3 solution. So the parameter is temperature, the time of duration of exposure from sample to the DTPA K2CO3 solution, and also with the help of assisted ultrasonication. Sorry. And then let's first start with the introduction, where it's the same. The first introduction is DTPA is an organic compound containing more than one electron, and then it able to remove the pyrite up to 45% more than the HCl. This is without the help of the help from K2CO3 or any kind of converting agent. So to evaluate the effectiveness of organic compound based on certain parameter, that's for our introduction. And then for our objective is basically we want to formulate a solution with three different ratios of DTP and K2CO3. The first ratio is 0.2 mole, 0.3 and 0.4. And the second objective is to assess the effect of time and temperature in dissolving the iron sulfide with newly formulated. So basically, we're focusing on time and also temperature for the second objective. And then for the third one is basically we want to evaluate whether the help of ultrasonicate can help further improve the dissolve rate. And then literature review, a little bit refresh from the previous, where I'm talking about the iron sulfide formed due to abiotic reaction, which is hydrogen and carbon seal, and also biotic, which is formed by minerals, clays, and tubular that move around inside the pipe. And then from the literature review, we have concluded that we want to use the DTPA and K2CO3 combination as one of the potential chelating agent that can be used. Okay, so for methodology, so basically how I do is basically I turn the experiment into three objectives, and then the first objective is basically I prepare the solution where three different ratios, and also before that the three different ratios are basically I prepare like this. So basically I have three samples. The sample is basically the solution. To prepare sample A, I need which is 0.2. I need to prepare 0.2 mole of 25 0.2 mole of 25 milliliter of DTPA, and then a combination of 5 milliliter of K2CO3 of 0.2 mole. So this is basically a ratio between two chemicals. And then for sample B, we use 0.3 of DTPA and constant K2CO3. And so sample C is basically 0.4 and 25 ml, and then the total volume for each sample is 30. So moving on for my objective 2. So basically objective 2, we are trying to focus whether the time exposure is able to increase the dissolve rate. So basically I am only able to make the experiment for 2 hours and 4 hours due to the time limit in the lab. And then moving on to my temperature result, which is at the room temperature, which is around 30 degrees Celsius, 40 degrees Celsius, and also 50 degrees Celsius. So after everything been done or treated, so we filter out the sample, and then we extract and collect the filtrate, and then that filtrate will be used for observation in the ICP OES and FTIR. So moving on, my objective 3 is basically we do that all again, basically from objective 2, but this time we include the presence of ultrasonic gate. So from here I want to find out whether the ultrasonic gate can help the reaction speed to be more faster. So moving on my data. So for this one is basically percentage loss based on the duration of exposure. So from here we can see the temperature is 30 degrees, and then the second one is 30 degrees with sonicate, and also 50 degrees and 50 degrees sonicate. So as we can see here, the longer the duration is sorry, let me explain a bit. The blue one is 2 hours, and then the orange one is the 4 hours. So we can see here that the just say on the 30 degree, the longer the concentration, so basically we have more percentage loss. But as you can see from the 50 degrees Celsius and the sonicate is quite high for the should I say the 2 hours, but for the 4 hours is quite low. So for this one, it is due to maybe we can theorize that the sonicate actually helps the duration, even though how should I say, in theory, the longer it is, the more basically the loss percentage. But we can see here, there's a how should I say, interference from the sonicate. Then we can see that maybe there's a little bit of influence in there. And then for this one, it's basically a chemical concentration to find out whether the higher the concentration, the better the dissolve. So we can see here at the 50 degrees Celsius, there's a little bit of confusion where 0.3 is higher. So supposedly, how should I say? Supposedly, the higher the concentration, supposedly the more better. But in this case, we can see that the 50 degrees Celsius, without the sonicate, it able to help boost the 0.3 concentration to have more higher chemical reaction. So for this one is basically a percentage loss against the temperature and the sonicate. And this time we have 0.2 uh, uh, sorry 0.2 we focus on temperature 50 degrees Celsius and 50 degrees Celsius of sonicate. So we can see based on the concentration of 0.2 and 2 hours, we can see that sonicate have a little bit of improvement towards the what should I say, the loss percentage. And I want you to focus on 0.3. So remember that the previous I said that maybe because of the interference of the sonicate, the 0.3 may not be able to perform or should I say good at 0.5 at 50 degrees Celsius with appearance of sonicate. So from here, the temperature at 50 degrees Celsius basically have higher performance than the one with the sonicate. And then moving on with this one is basically we want to find out what kind of element was there inside the material. So from here we can see that there's a lot of a lot of concentration of ferrum, and then followed up by barium, and also the least one is the lead. And then from here we can see that the higher the concentration, the more how should I say, the more concentrate of an element that can be extracted. And then I think that's all lah. And for my conclusion, that based on my research, all the three objectives were achieved based on the data of their percentage loss, and also the best formula to dissolve the samples is by using concentration of 0.3 mol of DTPA K2CO3 with the exposure duration of 4 hours at the temperature of 50 degrees Celsius. Maybe a little bit additional ultrasonic kit will result the best result. That's all. Thank you.